Right, so this is an example teaching video. Right, so let's get started with the induction to the first order differential equation. Right, as you can see, we start with this equation and then we have P and Q involving with X only. So the key step is to sort out the integrating factor. Okay, so as such, you have your integration factor, and then you are ready to then sort out your general solution. So your general solution should be in the form like this. Uh, as you can see, you can then separate that into your integration factor and your particular solution. Using an example to illustrate the idea. So for example, you have dy over dx minus 3y over x plus 1 equals something else on the right-hand side. So you first of all ignore the right-hand side. You simply just work out the integrating factor. Yeah, and then you have, once you have your standard integration sorted out, you then try to sort out your right-hand side. Okay, so you have to integrate both sides in order to figure out your final solution. So using some past exam questions as the actual practice. So for example, it is typical that you get asked to determine the general solution for this differential equation, right? With cos dy over dx, y sine x, and so on, okay? And so there are two parts. So the first part will be sorting this out, and the second part you have to plug in some value to work out whatever that they ask you to work out. So typically this is like 50% of the marks and 50% for the second part. So for the first part, you work out the integrating factor, looking at the left-hand side. And then after sorting that out, you look at the right-hand side and try to come up with the general solution. Once that is sorted out, part B will simply be plugging in the numbers to sort out for an answer. Right, using another example, uh, uh, um, so if you get given a function like this, yeah, so we have to showcase, this expression that is given. So we are now moving from differentiation to um, different functions. Okay, so this is expansions. Okay, so as you can see, in order to sort this out, you have to be able to spot the usage of the power law. So binomial expansion. So expanding using the expression given, we should be able to work this out without any issues. And apparently, the trick is that you have to swap back in the cos the trigonometry expression. So moving on, so this is 5 marks. So moving on to the other part, so you have to show a region bounded in figure 2, bounded by a curve, the line with equation, whatever, given to you. So the paper weight will be modeled by this expression, right? So you can imagine rotating this 180 degrees to form a solid. Okay, so we have to write down the value for h. So the key thing here is to do the integration correctly. Okay, so because you are rotating, so we are basically multiplying a vector by pi over 2. Okay, so we are integrating along x is here, and then you just sort out your integration. Okay, so just make sure that we don't trip over. And then we basically plug in the bounds, and then again, we will get the answer. So it is typical that people ask you for the limitation of the model, and it is important to make sure that we know that the limitation of the model is actually given by analyzing what is going on in the original function. So we have to make sure that we understand that, for example, in this case, we model the paper weight as perfectly smooth, but in reality cannot be perfectly smooth. So this is the limitation or the assumption of the actual modeling. Okay. So yeah, so this is binomial series. Okay. Moving on. So we have another type of questions regarding the cosh, the hyperbolic cosine, the hyperbolic trigonometry function. So using a data sheet, we should know the relationship between the integration, and the differentiation. So whenever you get asked to show certain things, you just need to make sure that you just plug it in, apply the identity correctly. Okay, so and then the complication here comes in when you have to do the square of the expression. Okay, and then applying the Maclaurin series. So this is again from a data sheet. So you just basically directly plug that in, and you should get it sorted out without any issues. Right. So after doing a little bit of maths, so let's switch to physics. Yeah. Okay. So the physics example here, let's start with waves. Okay, so waves, we have wavelength, we have amplitude, we have period. So the two equations, some two fundamental equations involving frequency, period, and wavelength are here. And so basically, this is the relationship between all these parameters. And the typical understanding in A level and GCSE involves the correct application of all those equations. Okay, so one of the work example is that once you are given the period or the speed, you have to work out the wavelength and so on. Okay, so these are typical questions, just asking you to define the application and what is meant by the parameter. So giving definitions. Right. So on to more slightly advanced topics. So this is about Snell's law. Okay, so when lights enter into different medium, they have different speed and hence they have different reflective index. And so we have to apply Snell's law to calculate the direction of travel and angle and so on, the angle of incidence and angle of reflectance. Okay, so this is a typical relationship described in this diagram. And for example, these are the typical questions, the real past paper questions, and they will ask you again, this a bit like what we have discussed. So the relationship between wavelength, frequency, and speed of travel. Okay, and so you will have to apply the correct formula. And in the multiple choice, it's easy to make mistakes regarding the calculation of diffraction grating. Okay, so you have to make sure that you understand what's going on regarding the diffraction grating and the formation of this pattern in order to back calculate the separation of the slits. Okay, so this is a very important diagram linking x and d and sine theta, which is the angle of the travel. And you have to also understand that you have different maximums. So in the center and then moving sideways due to diffraction. Okay, so this is typical questions regarding this setup. So there are a source and a screen, and you will get asked to calculate and the distance of different peaks, and you will also get asked to explain how the pattern shifts as you go from A to B, for example. Okay, and as you can see, they will give you numbers, so you have to plug it in to further elaborate. And essentially, you still make use of similar wave functions as described before, speed, frequency, and wavelength. Okay, and in GCSE or A levels, knowing the units are important, so making sure that we don't mess up the suitable value SI, sorry, the suitable SI unit for this constant. Okay, so this question 15 is a very typical questions regarding definitions. Okay, so apart from calculations, the conceptual understanding is important as well. Right, so moving on to one last bit of today example tutorial, which is again about waves, about reflection, total internal reflection, etc. So this is a continuation of the Snell's law. So imagine that you have refraction, yeah, in the typical sense, air-water interface. At the critical angle, you will have no refraction waves leaving the water, yeah, into air. So for total internal reflection, everything will be reflected back. And this is exactly what this question is about. So you have a design for windscreen wiper sensor. So this is setting the context. So in this question, you will get asked how to understand this design. So you have to apply your physical understanding to give an answer. Okay. So you also have to suggest some features commenting on the application of the windscreen glass. So 2 marks, 1 mark each. And then moving on to calculations, so they will ask you to use calculations involving reflective index to justify the operation of the design. Okay, and so as you can see, a lot of conceptual understanding. So even though you have to do calculations, but the main focus here is on the understanding. Okay, so you have to comment on the variation of the application. So again, so 2 marks. So the this is a very engineering question, even though it's in physics. So they, for example, they will ask you for what will be the factors affecting the sensitivity of the sensor and so on. Okay, so as you can see, the whole question is broken down into multiple sections involving small marks, right? 2 marks, 1 mark, and so on. So this is a very long questions, but essentially they are trying to guide you through the whole thing. And the absolute key focus of the question is the understanding of waves. Okay, so we all know that there will be internal reflection based on a refractive index. So you just need to justify what's going on with this particular system. So if it is windscreen involving the rain, so it will be air and water and glass interfaces. Okay, and so yeah, so this is last bit that I want to share within this video of today.